Hello and welcome to Autumn 2 Week 7 exam for Year 10s. A reminder that you need your green pen for marking and you need your blue pen for making annotations. Okay, let's get started. So we're looking here, question 1. Scientists investigated the effect of different factors on health. People who are not active may have health problems, and the graph shows the percentage of 16-year-olds in some countries who are not active. So let's have a look at our graph here. On the y-axis, we've got a percentage of 16-year-olds who aren't active, they're not doing regular exercise. And here's 5 countries: France, Germany, Italy, Netherlands, UK. Okay, and the bars are showing the percentage of the 16-year-olds for each country who aren't doing exercise. So what percentage of 16-year-olds in the UK are not active? So you need to look at the UK here. We need to go across with our ruler, and you can see I've drawn my dashed line here as I'm going across to measure off the y-axis. Now it's somewhere between 60 and 70, so I need to know what each of these little boxes is worth. Between 0 and 10, I've got 5 little boxes, so that means each little box is worth 10 divided by 5, which is 2, so each little box is worth 2%, so we go 60, 60%, 62, 64% on there. 1 mark for that. And then what percentage of 16-year-olds in the UK are active? So that would be 100%, all of them, minus that 64%, gives us 36% for 1 mark. Okay. Let's have a look. 1A. A newspaper headline states, people in the UK are the laziest in the world. Information in figure 1 does not support the newspaper headline. Suggest one reason why the newspaper headline may be wrong. So it's telling us that this graph does not support this headline, that people in the UK are the laziest in the world. And it's a little bit confusing because at the beginning, when you first look at this, you might say, well, it does support that they're the laziest in the world. Look, the bar for people who are not active in the UK is the highest, so surely it does support it. But actually that's not true, and that's to do with 2 things in the headline. 1 is it just says people, and 2, it says the world. Okay, let me explain what I mean by both those things. So because it's talking about all the people in the UK, then you'd have to have data support that claim that the whole population is lazy. But here our graph is just talking about 16-year-olds. So therefore, this graph is not supporting that headline. So one reason you can say is that the data only considers 16-year-olds, not the whole population of the UK. It also says we're the laziest in the whole world. Well, if we have a look at the graph, this data is only showing information from 5 different countries: France, Germany, Italy, Netherlands, UK, not the rest of the countries in the world. Okay, so we can say that the data is only considering 5 countries, not the entire world. One of those for 1 mark. 1B. Doctors gave a percentage rating to the health of 16-year-olds. 100% is perfect health. The table shows the look at this table.
This column is telling us the amount of exercise that people do in minutes every week. So we've got less than 30, then 90, 180, 300, and their health rating. And it's asking what conclusion can be made about the effect of exercise on health. Well, as you do more exercise, the healthier the person becomes. That's what that table is roughly telling us there. We see as I do more exercise here, better health rating. 1 mark for that. Inherited factors, so factors passed down from your parents in your genes, can also affect your health. Give one problem that may be affected by the genes someone inherits. So there's 3 answers here. Being malnourished, that means not getting enough food, having a high cholesterol level, and having a deficiency disease. Having deficiency disease means you don't get enough of a certain type of vitamin or mineral. Okay, so being malnourished and having a deficiency disease are purely about your diet. Not eating enough food, not eating enough of a certain vitamin or mineral. Having a high cholesterol level is also dependent on your diet. If you're eating very fatty foods, you're going to have a high cholesterol level, but it can also be dependent on your genes as well. So that's why that is the correct answer for 1 mark. 1D. White blood cells are part of the immune system. Use the correct answer from the box to complete each sentence. So antibiotics, antibodies, pathogens, vaccines,
When we're ill, white blood cells produce antibodies to kill microorganisms. Remember, they can also produce antitoxins. They can also carry out phagocytosis as well. Many strains of bacteria, including MRSA, have developed resistance to drugs called antibiotics. 1 mark for each of those. Okay. Question 2. Diet and exercise affect health. Many people are obese, which means very overweight, and obesity can lead to heart disease. Other than heart disease, so we can't talk about things like CHD, coronary heart disease, name 2 conditions which are linked to obesity. Right, so there's a whole list you can have there here. You could have said arthritis, which is when the cartilage in your joints starts to get worn down because it's been used over and over again, and that happens, you know, quite a lot in elderly people, but also people who are more obese. It puts more pressure on their joints. Diabetes, like we spoke about in class, high blood pressure, a stroke. A stroke is basically when you get a blood clot on your brain, and also breathing difficulties as well. Okay, being obese can put lots of pressure on your lungs. Okay, any of those 2 for 2 marks. Okay, 2b. The graph shows the number of deaths from heart disease each year in the UK. Here it is, and there's lots of information on this graph. Let's just start by having a look at a few of these pieces of information we've got here. So on the y-axis, you have the number of deaths from heart disease per year. Okay, so we've got 2,000, 4,000, 6,000, 8,000, 10,000, 12,000. And on the y-axis, you've got the age range in years. Okay, from sort of 0 to 5, 5 to 10, 10 to 15, and so on, all the way up to over 95 there. And you've got this key. So the lighter coloured bars are males, and the darker colour are females. Okay, and we can see as people are getting older, generally we see more deaths of heart disease, and it starts to drop down as people get really, really old, you know, 90, 95. The patterns for deaths from heart disease in men is different from the pattern in women. So we can see a difference between these 2 coloured bars. Give 2 differences between the patterns for men and women. Okay, well, there's lots of different things you could write down here. We're going to go through each point. So there's a lower number of women deaths up to 75. So if we look up to 75, before this point, less women, the darker bar, are dying than men. Okay, so that's one difference we could have put down for a mark. There's a high number of deaths after 80 for the women. So again, if we have a look after 80, the darker bar is higher up. And for any of these points, you can write it the other way around. So you could have written high number of deaths in men up to 75, a lower number of deaths in men after 80. 2 more points. You could have said the men's peak is higher. So you could see here's the peak for the men at 75. Here's the peak for the women at 85. The men's peak is higher, and the men's peak at an earlier age as well than women. Men's deaths start earlier than women as well. You can see here women start dying between 40 and 45, whereas men start dying between 35 and 40. So men start dying earlier than women. And also the last point you could have got, you could have said more men than women die of heart disease. And if you got that point, well done, because you would have had to have worked out the totals for each of these bars and added them up to make that comparison. Any 2 of those for your 2 marks there. Suggest 2 reasons for the difference in the number of deaths from heart disease in men and women between the ages of 40 and 60. Let's just focus this. So we're looking specifically, and I've underlined here when I've bugged, between 40 and 60. Up here,
we're not looking at anything over 60, and we're not looking at anything under 40. So we're just looking at this age range here, okay? We're looking to try and explain the differences between the men and the women. So, possible differences. There's loads of different things you could have written for answers here because it's a suggest question, so there tends to be quite a lot of things you can have for your marks. We could have said men smoke more, so that means when men smoke, they smoke more cigarettes than women, or more men smoke. So there's a higher number of men who take part in smoking than women. These are just suggest questions, it might not be true. Men could possibly be under more stress. You know, that's an environmental factor that can lead to heart disease. And also men might be less active. Women might possibly do more exercise than men. We know exercise reduces heart disease.
there could be more men that are overweight, or it could be certain genetic factors that are linked to being a man as well. We could have said men have a lower metabolic rate. Remember, that's the speed of the chemical reactions going on in your cells, in your body. So if you've got a lower metabolic rate, you've got slower metabolism, you might have heard that phrase, slower metabolism, then it's harder to lose weight and you're more likely to be overweight and have heart disease. And the last one is that men are less likely to visit the doctor when they have symptoms. Okay, so even if the men notice that they have the symptoms of heart disease, they might not go to a doctor, and that could make them more likely to die. So if you've ever got the symptoms of a disease, you need to make sure you go see your doctor. Any two of those for those 2 marks there. Okay, question 3. Number of people in the UK with tumours is increasing. And question 3AI asks us to describe how tumours form. Nice and simple. Tumours are an uncontrolled division of cells. So cells divide uncontrollably, you could say. Tumours can be malignant or benign. Just a reminder that malignant tumours are cancerous, benign ones are non-cancerous. And the difference between a benign and a malignant tumour, what is it that makes this one cancerous and makes this one benign, is that benign tumours do not spread, or you could have said they do not cause secondary tumours. Some of the cells in our malignant tumours, they break up that membrane, they get into our blood, and they move around the body, they attach to other organs, and they form more tumours called secondary tumours. Okay, the benign ones don't do that. That's why they're non-cancerous. And so how might they spread? That is via the blood, or you could have said via the circulatory system. 1 mark for that. Okay, 3C. People from Northern Europe have fair skin, so that means light coloured skin, and many people have malignant melanoma skin cancer. Okay, so that's a cancerous form of skin cancer, right? The graph shows how the number of people in the UK with malignant melanoma changed between 1985 and 2008. Right, before we have a look at that, I'm just going to make a little annotation about skin cancer, is that it's caused by UV, so ultraviolet radiation from sunlight. Okay, so that's why whenever you go on holiday or it's a really sunny day here in the UK, you're always advised to put on sun cream to try and stop this UV radiation getting to your sun, because it can increase your risk of getting skin cancer. Okay, so the line graph is showing us the number of people with malignant melanoma. The bars on the graph show the number of people in the UK who travelled abroad and the number who took cheap holidays in the sun in 1985 and 2005. Okay, so let's have a look at this graph here before I show you all my annotations. We've got lots of information shown by the lines.
And we've got on the bars the number of people who took the total number of trips abroad, the lighter colour, and number of people who took cheap holidays in the sun, a darker colour. We're going to make a few annotations about this graph and what it's telling us. So the first thing we can notice is between 1985 and 2005, if we start with the bars, that as we've gone on 20 years in the future, people are going on holiday more. We can see the total number of trips and the cheap holidays in the sun has increased. So that's the first thing I annotated down here, is that the number of holidays that people are going on is increasing. Let's have a look back, looking at my lines. Also, if we have a look at the number of people with malignant melanoma, with skin cancer, the general trend I'm looking at here is that over time the cases of skin cancer have increased. You could say the incidence of the disease has increased. Okay, so that's what I annotated on here. The incidence, how common the disease is, that is increasing over time. Those lines are going up. Now, they're not going up evenly, because if we're going to have a look and we're going to say draw a line following on this trend, the line should carry on in this direction, but you can see it curves upwards, especially more recently. Okay, so I'm noticing that in more recent times, the number of cases of skin cancer has quite rapidly increased. Actually, it's really curving upwards quite recently. So I've annotated that on my graph, that not only is the incidence increasing, but it's increasing more
it's more increasing rapidly more recently. And last thing I noticed about this graph is that not only is it increasing more rapidly recently, but it's increasing more rapidly with this line rather than this line. This line represents the number of people for poor areas with skin cancer. Okay, so this one is the one for poor areas, this one at the top is rich areas. So I'm noticing skin cancer increasing more rapidly recently in poorer areas than in richer areas. Okay, and that's what I've annotated on here. It's increasing fastest in the poor areas. Now the overall trend, if we just have a look at this graph, what it's sort of telling us here is this. People are going on more holidays. That means they're going to be exposed to more sun, therefore more UV radiation, and therefore we're seeing more cases of malignant melanoma. That's the sort of the general trend of what's going on, but obviously there's lots of details in there that we've annotated also. Let's have a look at the question now. So, describe the trends in the number of people with malignant melanoma skin cancer between 1985 and 2008. So we want to describe those trends. Well, we're just going to use what we annotated on the graph here. First of all, the incidence of malignant melanoma is increasing. That was the first thing that we annotated on there. The number of cases was going up. The incidence was increasing more rapidly recently, and the incidence was rising fastest in poor areas. So there's 3 different points you could have there. A fourth one you are also allowed, and we didn't have a look at this on the graph, is that the difference between the rich and the poor areas is decreasing. Let's have a look at what that means. If we have a look at the difference here between rich and poor in terms of the number of cases of skin cancer, is much larger than it is here in 2005. So that difference between rich and poor has decreased. You could have that for a mark. You need 3 of those points for 3 marks. 3C I on to suggest an
explanation for the trends you have described in part CI. So we're trying to suggest a reason for what we're seeing up here, what we've stated about the number of cases of skin cancer. So, first of all, what I want to say is that UV radiation is a risk factor of malignant melanoma. Remember, a risk factor is some sort of factor linked to the development of a disease. So UV radiation is linked to people developing malignant melanoma. We also said there were more trips abroad, holidays in the sun, and of course if there's more trips abroad, holidays in the sun, then more UV radiation and therefore increased chance of malignant melanoma. Also, poorer people can afford to go on cheaper holidays in the sun. Right, so it's not just the rich anymore who can afford to go on these holidays. Poorer people are exposed to more UV radiation. That's why we're seeing such an increase in malignant melanoma from those poorer areas. You only need 2 of those for your 2 marks.
Okay. Some animals have a single double circulatory system. Below is a diagram of a human heart. I've just started off, whenever I get a diagram of a heart, labelling it. So I've labelled the right atrium, right ventricle, left atrium, left ventricle. I've done arrows to show the direction of blood flow. I have annotated the main blood vessels as well. So the vena cava, where the blood is coming in, pulmonary artery going out. We can always remember that because we know from this side, from the right side, the blood is going to the lungs, so it must be pulmonary. A for away, it's going away from the heart, so it must be an artery. Coming back from the lungs, so it's pulmonary, it's coming back in, so it's a vein, it's going into the heart, pulmonary vein. And then the last one, pumping the blood to the rest of the body, is the aorta. Okay, so I'm just labelling that on when I see a diagram of the heart, just to make sure everything's nice and clear. Which label shows the pulmonary vein? Already labelled that, D, for 1 mark. Which blood vessel takes oxygenated blood away from the heart? So if the blood is going to be oxygenated, it must have just come back from the lungs. So that's going to be the pulmonary vein, bringing it in from the lungs. So this side's got oxygenated blood. It's going to do taken away from the heart to the rest of the body. So that's the aorta, that is C. Okay, Next question. In a scientific investigation, over 44,000 men were monitored for 12 years. It's a big study. The men were divided into 4 groups based on their numbers of hours of physical activity they did per week. Okay, so we've got 44,000 men, and they're based on how much exercise they did. Okay, so they put people in one group who only did 1 hour per week, another group who did 5 hours per week, another group who did 12 hours per week, and another group who did 24 hours per week. Okay, and they've also taken all this other data about them at the same time over these 12 years. They've looked at what percentage of the group smokers, what percentage have high cholesterol, what percentage have a family history of heart disease, the mean percentage of fat that's in the diet, and the number, and notice how I stopped saying percentage now, it just says the number of cases of heart disease. That's going to be really important later on. Okay, it's not the percentage. Okay, 2 other factors which may affect the risk of heart disease. So factors, we can't say the factors that are in the table. We could say their weight, or them being obese, you could say that, their age, the type of activity they're doing, their blood pressure, or what is in the rest of their diet. For example, you know, we said here is the percentage of fat, so we can't say that, but we could say the percentage of fibre, we could say the amount of protein, the amount of sugar maybe in their diet as well. Any of those parts of diet could get you a mark, 2 of those are 2 marks. All of those are risk factors of heart disease. Okay, I'm keeping that table to the side just for the moment because we're going to come and look back at it in a minute. 4E asks us to evaluate. So before we read the question, let's just have a reminder what evaluate means. It's going to be one of the trickiest questions you face in GCSE science. Evaluate means you need to write down points for and points that are against whatever the question is arguing. You need to use information provided, but you can also bring in your own knowledge as well. And you need to write a justified conclusion. It's not just a conclusion, it needs to be justified, which means it's linking back to the points, the arguments you made beforehand. Okay. So, the question is asking to evaluate whether the data shows that increased hours of physical activity reduce the risk of heart disease. So, does doing more exercise reduce the risk that your heart is going to be diseased? We need to use information from this table to help us. Okay, I'm going to start off by making points 4. So, the biggest point 4, if we have a look, that as the amount of exercise people are doing is increasing, it goes 1, 5, 12, 24 hours, that's increasing, the number of cases of heart disease is decreasing. So that is really strongly supporting that argument that is made in the question. So that's the first point that I'm going to write for. As the hours of activity increased, the number of cases of heart disease decreased. Some other points you could write for as well is that cholesterol and family history do not correlate with heart disease. So we have a look here. As the case of heart disease are going down, cholesterol, family history of heart disease are staying the same. So it looks likely that the amount of cholesterol or the family history are not affecting whether these people get heart disease or not, from what that data is showing at the moment. And the last one you could have written down was saying that increasing the hours from low numbers, so W to X, so we can see here, increasing from W to X, you know, doing 5 times the amount of exercise, reduces cases more than in the high numbers, where you're only doing twice the amount of exercise. We can see here, doing 5 times the amount of exercise, we're going from 323 to 370, and that's a bigger decrease than going from 1224, where we're doubling the amount of exercise. It's not as big a decrease in heart disease. Okay, so that helps to support our point as well. The more exercise that you do, the more times you double or triple the amount of exercise you're doing, the more likely it is to bring down the amount of heart disease. Right, points against. So, first of all, is smoking and the percentage fat correlate with the heart disease? Let's have a look at that again. So here we go, we can have a look at the percentage of fat in the diet. As the percentage of fat is decreasing, the number of cases of heart disease decreasing. The same as smoking. As smoking decreases, heart disease decreases. So that reduces our argument where we said that it was the number of hours increasing that caused this change. It could be the smoking or the percentage of fat in the diet that is causing this reduction in heart disease. We don't know, so that's why it's a point against. Smoking correlates with a decrease in exercise is your next point. So we have a look here. As smoking decreases, people are doing more exercise. Well, is the smoking causing people to do less exercise? Is the smoking decrease causing people to do more exercise? Is it the fact that people are exercising more causes them to smoke less? And which one is it that could be causing the number of cases of heart disease? It's not clear from that data. You'd have to do some different studies to work that out. Okay, next point. We only studied men, not women or children. Remember, the question is saying that increased hours of physical activity reduce the risk of heart disease. So that statement would be applying to all people. But our data was only about men. So even if this data does say that more exercise decreased heart disease, we can only say that's true for men. We can't say that's true for women or children. So that's an argument against this general statement about people. And last one is probably the most convincing argument against that statement, is it is unknown what percentage of men in each group have heart disease. Let me explain what I mean by that. Remember, we took 44,000 men and they were divided into 4 groups. But it doesn't say they were divided into 4 even groups. It doesn't say that there was 11,000 in each group. I could have 41,000 in W and 1,000 in each of these. Okay? So, we don't know how many men are in each group. We only know the number of cases of heart disease, but not the percentage of people in each group with heart disease. That's a really big difference, because if there's 41,000 people in W and only 423 cases of heart disease, well, that's a really low amount of people with heart disease compared to the number of people. But if, say, there's only 500 people in W and there's 423 cases of heart disease, that's a really high percentage, which tells me, actually know
the percentage of people in each group that have heart disease. So this data really doesn't tell us very much in terms of how these factors affect the cases of heart disease. So this, I think, is the most convincing argument of them all.
Now, if you've got all of those, even if you've got them word for word how I've got them written down there, you can't have all 6 of your marks. That is because, remember, it's an evaluate question. So we need to write a justified conclusion. So you should need to have at the end a statement that looks something like this. In conclusion, I think the data does or does not show that an increased hours of physical activity reduce the risk of heart disease. So you need to say whether you agree or not with that statement. Even then you can't have all your marks because you need to justify it. So you need to say this is because, and you need to link it back to previous points. You might say, I do agree with it because the data shows that as the hours are increasing, the number of cases of heart disease have decreased. Or you might say, I don't agree because the study only showed men. It didn't show women or children. So you can't make a judgment about all people. Okay, so you need to be using those points to back up whatever conclusion you made. If you didn't write a conclusion, but you've got lots of these points, so say you've got 2 from for and 2 for against, you can have 4 marks there, but you get an extra mark for writing a conclusion and an extra mark for writing that link to your previous points, justifying your conclusion. That's how you'll get your 6 marks. Once you've marked that, remember to add it up and write your mark on the front cover here.